math! It's math! I got it! Please. Come on, it's math! Oh, okay, welcome to math. Here we go. So, is that good? Welcome to math. All right, is it good? It's great. Okay, thanks guys, welcome to math. We are talking about patterns today, and I love patterns so much, I stopped drinking water and came down to do math. All right, and here we are. So, what you need to know about patterns, and in particular, growing patterns this week, is they're changing in our case in these patterns by the same thing, okay? There exists non-linear patterns that change by a different thing each time. We're not talking about those. So for this week, for today, we're talking about patterns that change the same way. So for example, if I have a pattern like this, 6, 11, 16, 21. Okay? What can you tell me about my pattern? Something about my pattern. Yes, Susie.
It goes up by 5 each time.
Up by 5 each time. Okay?
I'm a man.
So it goes up by 5 each time. Okay? It'll keep doing that. One more thing you can tell me about my pattern. Yeah, Dracula.
My name is not Dracula, it is Donald J. Trump. And it starts at 6, my friend.
That's fantastic. It's fabulous.
Also, do not vote for Justin Trudeau. He's a maniac.
Thank you, Mr. Trump. Okay, so 2 things, and that's perfect. Thank you, Trump. My pattern starts at 6 and goes up by 5 each time. Okay? 2 things to know. Now, we are going to work on one of my favorite things in math. A table of values or a patterning table. Okay? This tells me 2 things. The term of the pattern and what that term is worth. So, for example, the first term, term number 1, what is its value? What is the value of term number 1? What is the value of term number 1? Consuelo?
6.
It is 6. Absolutely. Okay. What is the value of term number 2? Janine?
11.
11. What is the value of term number 3? Senorita?
16.
16 is the right answer. Awesome. And the value of term number 4? Qui-Gon?
21.
21 is the answer. Okay. So, here's the value of a patterning table, okay? And I will, on, for example, a quiz, ask you a question like this. I might say, what is the value of the 10th term? Okay? Now, the patterning table allows you to see patterns, Talia, in your pattern. So, for example, sometimes there's patterns across the table like this, and sometimes there's patterns down the table like that, but there's always patterns. So, for example, we know that this is growing by 5 each time, okay? What I didn't realize when we first made this video and only discovered now as we're watching it again is this crazy fact. There is, in fact, a pattern across the table here. Now, you'll see in a minute, we don't find it originally. When we went back and watched it again, we found a pattern across the table. Look at this. And term 1 times 5, okay, gives us 5, plus 1 is 6. 2 times 5 is 10, plus 1 is 11. 3 times 5 is 15, plus 1 is 16. 4 times 5 is 20, plus 1 is 21. So actually, one of our patterning rules can be like this, n times 5 plus 1. So n being the term, times 5 plus 1. Now, I put this in brackets like this because we're doing math. Those brackets tell me to do that part first and then add 1, okay? If I try and do n times and then add the 5 plus 1 and do n times 6, this won't work, okay? So I do this part first. So one of my patterning rules could be n times 5 plus 1. Now, if I'd had more time in the first video here, I would have worked that out by looking at how this is changing and maybe seeing, oh yeah, you know what? I do see that 2 times 5 is 10. That's 11, so it's not quite there. 3 times 5 is 15. That's not quite there. And then maybe realized what was happening here. That it actually is times 5 plus 1 each time. Okay? Back to your regularly scheduled video. You can also ask yourself, is there a pattern like this? Can I times 2 by anything to get 11? Or 3 and get 16? Or 4 and get 21? There's not. Okay? It might take a bit of figuring this out. Just trying 3 times something, 3 times something, to see if there's a pattern there. You realize there's not. So in this case, there's no relationship down across the table. There is one down the table. Okay? So in the question like this, I can keep going. To learn the 10th pattern, I would do the 5th term, the 6th term, the 7th term, and eventually I would get to the 10th term. Okay? Let's do another one. That has a relationship across the table too. And we'll talk about how we can write this. Okay. Okay. 12, 24, 36. Okay. There's our term. There's our value. First term is worth what? Gary? Yeah, you're Gary, aren't you?
12.
12. Our first term is worth 12. Second term is worth what? Chiquenta.
Mr. Donaldson, it's 5.
Thank you, Mr. Donaldson. Am I Mr. 5?
No, you're Mr. Donaldson, and I'm a Discord mod.
Thank you. 24 is the answer. Our third term, Qui-Gon?
36.
36. Okay. All right. Try it again now. Okay? There's a relationship across the table and down the table. Okay? This is where patterning tables become very powerful. So what's happening like this? Okay? How's our pattern changing down the table like that? Okay? Samantha?
Excuse me, I'm not sir. I'm Mr. Rocco Howard. That's only 3. But
Wow, okay.
You can call me Rocky.
Okay, Rocky.
Okay, it's 12.
It's 12. Thank you, Rocky. So, our pattern is changing by 12. So we're adding 12 each time. Okay? That is true. But if I want to use this even more powerfully, I can call the term n. N's a variable that can stand for any number. Okay?
Okay.
Of my term. So, n. What's happening across the table here? And here. And here. Anyone see it? N times what equals 12? So if I put the 1 in place of the n, 1 times what equals 12? Bob?
Oopsie, my English translator wasn't working.
Okay, turn it on.
I think it's 12.
It's 12. Okay? So n times 12 equals 12. So if I put the 1 in there for 12, so 1 times 12, I get 12. If I put a 2 in place of the n, what's 2 times 12? What's 2 times 12? Gary?
24.
24 is right. Be careful, Gary. Don't hurt yourself. If I put a 3 in place of the n, what's 3 times 12? What's 3 times 12? Yeah, Winston?
I'm Gary's great-great-great-grandpa.
Congratulations.
It is 36.
It is 36. Absolutely. Thank you. Be careful there. Don't. Oh, wow. Okay. So my pattern rule is n times 12 or plus 12 each time. Okay? And where this is powerful is I can plug in any number for n and get the answer. So I can ask you, what is the 10th term in this pattern? You put a 10 in there and do 10 times 12 and get the 10th term. Okay? As 120. Okay? I could say, what is the 5th term of this pattern? And you can add the 2nd term and the 3rd term to get the 5th term. Okay? It's very powerful. So when your pattern is growing like this, when there's a relationship across the table like that, you can use this patterning table to get your answer very quickly and very efficiently. Okay? It's a great tool. So you see a pattern, make a patterning table, and see if there are math hacks like this you can use to solve the pattern quickly by looking for those relationships across the table and down the table. Okay? Thanks for watching. Like, subscribe, and feed your ferrets.